Hey guys, so a wonderful day. So for today, we are going to be learning on the second subtopic of the second chapter. So the second chapter was atomic structure. So the second subtopic that we are going to learn for today is quantum mechanical model. Okay, please pay attention because this part is very crucial as it will also bring up to your fourth chapter for this semester one. Okay, now quantum mechanical model. Okay, this is basically the newer version, all right? Initially, it was Bohr's atomic model and stuff. Now we're going to learn on quantum mechanical model, which is the modern style, all right? So, mechanical model, number one, an orbiter is described as having an allowed shape and energy of electron waves. Okay, the basic concept of quantum mechanical model is that according to a quantum mechanic, we should represent things by atomic orbital. And what does the atomic orbital mean and state in based on this quantum mechanical model? An orbital is described as having an allowed shape and energy of electron waves. That's number one. Number two, the electron is described as occupying a 3D space around the nucleus. I repeat, the electron is described as occupying a 3D space around the nucleus. Number three, the nucleus is said to be surrounded by an electron cloud. Okay, so based on all this stuff, according to quantum mechanical model, we have a couple of things that we need to know. Okay, so we have atomic orbitals based on the quantum mechanical model. We have three types of orbital: s orbital, p orbital, and d orbital that we're going to learn for matriculation syllabus. Okay, number one, we are going to learn on the shapes of the orbital first. All right, number one, we have s orbital over here. I'm going to draw it in blue. S orbital. Okay, you guys know in mathematics we do this y-axis and x-axis. Same thing over here, but just a little bit of adjustment. For S orbital, you draw it Z. Okay, we have Y, and then we have X. All right, this will be your X axis. Z, Y, X. S orbital, the shape is just a circle. This is the simplest orbital ever. It's just a circle. Okay, make sure in the center it is not, okay, it's something like this. All right, but please make sure you guys show the axis because axis is very important, and please show the cut through of the x-axis too. Okay, that is for s orbital. There's only one orbit, one type of shape for s orbital. Let's go to p orbital. For p orbital, there's three types of shape. Okay, number one, same thing, z, y, and x. Okay, for p orbital, there's three types. Number one, it moves through the x-axis. Okay, that is number one. Okay, it only surrounds the x-axis, remember. Okay, only surrounds x-axis. Make sure it doesn't touch the z and y-axis. All right, please draw properly. Number two, same thing, z, y, and x. You can put the x down or above, doesn't matter. Number two is the one which touches the y-axis only. It's like a leaf shape, okay? Clover leaf shape, y-axis only. Make sure it doesn't touch the x and z. Not doesn't touch at all. Just make sure it doesn't touch the majority part of z and x-axis because this covers y-axis, this covers the x-axis. Number three. Number three, same thing. Draw first z, y, and x. This time it covers the z-axis. Okay. Cloverleaf shape, same thing, covers the z-axis. All right, those are the three shapes of orbital that we need to know for p orbital. Okay, we have s, p covered. Now we are going to do d orbital. Okay, for d orbital, it's a little bit more. Just now was 1 for s, 3 for p. D orbital will be 5. Okay, so the first orbital, same thing. you have to draw your Z, your Y, and your X first. Okay, so the first one will revolve around the Z orbit. Okay, if this revolves only around Z orbit, this will be under P orbital. But for D orbital, revolves around Z axis and also Y axis. For you guys to show how does it revolve around Y axis, just draw like a dumbbell shape. Okay, just a circular part, a dumbbell shape. Okay, all right. This will be called dz square. Number two. Number two, same thing. You gotta draw first z, y, and x. Okay. So for number two, this will be passing x and y. Okay. When I say passing, literally means x and y. Okay. This is literally passing through. So this is what we call dx square minus y square. See, x is passing through, y it's passing through. Over here, only z it's passing through. Okay, all right. To differentiate between p and d orbital, that's why you have to draw like this dumbbell shape at the y-axis. Okay, next, number three. Same thing, z, y, and x. This time, it'll be passing through x and y. Okay, if it passes through x and y, this will be dx square minus y square. But it's now in between x and y, which means y is over here. It's in between x and y. Okay, it's in between x and y. All right, between and in between. Okay, I'm gonna note here in between, and this is passes. Okay, this will be dxy. Okay, that is number one, number two, number three, number four. Let's have a look at number four. Z, Y, and X. This one, for this time, it will be, let me draw first and then you guys guess the notation for it, okay? It'll be over here. It'll be over here. It'll be over here. And it'll be over here. Okay, it's literally in between Z and Y axis. Okay, everything is between Z and Y axis. This is what we call dyz. Okay, for this, there is no need for you guys to show the x-axis. It's not compulsory. Okay, you guys just show the movement in between of Z and Y and you name it dyz. Okay, that's good enough. Number 5. Tadi sudah dzy. Dyz. Okay, now apa yang missing? Dxz. So what do? Z, just replace the y-axis with x over here. You guys know very well, once you replace, you have to remove one of the axes. Belah sini kita dah remove x. Belah sini just remove y. Draw the same thing over here. Okay, and you call it dxz. Okay, it's very, very important for you guys to take note which one goes in between and which one passes through the axis. Okay, that's number 1. Number 2, make sure your naming it's dyz, equal alphabet, follow the alphabetical order. Don't put dzy, it's dyz. All right, okay, these are the shapes of s, p, and d orbital. Now let's have a look at what we're going to learn further which relates to this s, p, and d orbital. Okay, now an orbital has 4 quantum numbers. Okay, now let's learn on quantum numbers. This is very related to the orbitals that we learned just now. Okay, number 1, we are going to be learning on principal quantum number. Principal quantum number is denoted as n, small letter n. Dulu korang dah belajar kan n equals to 1, n equals to 2, those are the things, right? The shells, right? Okay, it's almost the same over here. Number 2, angular momentum quantum number. Okay, this now was principal quantum number denoted by n. Now angular momentum quantum number denoted by L. Number 3, magnetic quantum number. It is denoted by small letter m. And number 4, electron spin quantum number. Electron spin quantum number denoted by S. So NLMS, that is the order, NLMS. Okay, now let's have a look one by one. Before I move on, let me just emphasize you guys to write a set of quantum numbers must in this sequence. Bracket NLMS. Now, let's have a look of how does this NLMS thing work. Number 1, let's go one by one. Let's go for N. What is N? N is principal quantum number. Okay, principal quantum numbers shows the main energy levels. Okay, you guys know sebelum ni dah belajar energy levels is N equals to 1, and N equals to 2, and so on. Same thing over here. And remember, it's always positive integers, okay? Akan jadi 1, 2, 3, 4, and so on, okay? It will never be negative, okay? Please take note, N equals to 1 is the lowest energy level, and it's also the nearest to nucleus, okay? N is also referred to as electron shells. Sebab you guys dah belajar dulu, N equals to 1 is the first shell, N equals to 2 is the second shell. So N is also referred as electron shells. Okay. Now, same thing, N is 1. N equals to 2. 1 meaning nucleus kan? 1. 2 meaning 2. Okay, the electron is at the second orbital. Okay, basically N equals to 3. It's just getting bigger and bigger. 1, 2, 3. That's just the meaning of it. Okay, now that is N. Let's have a look at what is L. Okay, for L, it is angular momentum quantum number. Okay, L indicates the shape of the orbital. Okay, macam mana nak tahu shape dia apa? Kan tadi kita dah belajar S, P, and D orbital. L over here, the value of L indicates the shape of the orbital. Okay, sama ada dia S, P atau D. Okay. It is also referred as subshell. Okay, kalau ada shell, tadi tu shell, sekarang ini subshell. Value of L is equals to N tolak 1. Tadi kan N, kita dah belajar N. Anything N tolak 1 equals to the value of L. Okay, L ni is also known as, dia boleh guna nama lain, which is azimuthal AZI, my bad spelling, AZI MUTHAL, AZI MUTHAL, azimuthal subsidiary and orbital quantum number. Okay, tiga-tiga ni boleh guna, so jangan confuse or jangan panic if they use different terms to represent L. Okay, now let's have a look in detail how does L works. Okay, now let's say N equals to 1. L akan jadi apa? L akan jadi N tolak 1 kan? So 1 tolak 1 equals apa? Kosong. The moment L equals to kosong, your shell will be S, because S shape. Sebab L ni indicates shape. Okay, so dia akan jadi S orbital punya shape. S orbital punya shape apa? Kita dah belajar dekat sini, S orbital punya shape adalah Yang ini. Alright? Okay. Now back to here. Next, if n equals to 2, n equals to 2. Maksud dia, when n equals to 2, L equals to n minus 1. 2 minus 1 equals to 1. Okay. Over here, when n equals to 2, L equals to 1. L ni equals to 1 doesn't necessarily mean dia adalah untuk P shape sahaja. Dia boleh juga represent L shape. Okay. Untuk L, dia special case. Let's say dia 3. Okay. Value of L 3. Dia boleh jadi 0, 1, 2. Anything which is N3. Anything which is 3 and lower. Dia boleh represent. Okay. Let's say L equals to 2. Dia boleh jadi 0, 1, 2. L equals to 1, dia boleh jadi 0, 1. L equals to 0, kosong lah. Okay, anything which is that number and lower. Okay, alright, sini akan jadi 1. Jadi kalau 1, dia akan jadi apa? 0 and 1, which is S orbital and P orbital. Next, N equals to 3. L akan jadi apa? 2, kan? So, kalau 2, dia akan jadi apa? 0, 1, 2. 0 is S orbital, 1 is P orbital, 2 is D orbital. N equals to 4, L will be 3. So, dia akan jadi 0, 1, 2, 3. 0 will be S orbital, 1 will be P orbital, 2 will be D orbital, 3 will be F orbital. F orbital not so significant for your syllabus, but just know that 3 is F orbital. Okay? Alright, that is what L means. Now, N sudah settle, L sudah settle. Now, let's go to M. How do you do M? For over here, M. M maksud dia apa? Magnetic quantum number. Magnetic quantum number basically describes the orientation of orbital in space. Space dia apa? 3D space lah. Sebab kita dah belajar tadi tentang quantum mechanical model. So over here, magnetic quantum number describes the orientation of the orbital in space. Okay. Permitted value of M, basically value of M depends on value of L. Okay, dia macam sequence. N akan ada satu value. N satu value, L akan depend kepada N. Okay, sebab untuk value L adalah N tolak 1 kan? Over here M akan depend kepada value L. Okay, it's all dependent. So, untuk M pula, dia adalah 2L tambah 1. Okay, 2L tambah 1. That is the values permitted of M. So, also to be remembered, one orbit can take a maximum up to 2 electrons. 2 electrons. Okay? Alright. Remember this and remember this. Also this. Very important stuff. Now, let's have a look at how M actually works. Alright. Kalau L tadi kosong, M akan jadi kosong lah kan. Jadi shell dia adalah S orbital. Number of orbit 1. Kenapa? Sebab if you look at the shape of S orbital, let's take a look back over here. S orbital, 1 orbit. Okay, 1 orbit according to the theory that we learn over here, 1 orbit maximum of 2 electrons. Sebab itu dekat sini kalau L kosong, M jadi kosong. Sebab M dependent on L. So S orbital 1. The moment 1 orbit, 2 electrons je. Okay. Next. L equals to 1. Okay. 2L tambah 1 adalah value untuk M kan? So 2 darab 1 tambah 1 jadi 3. Okay. Tak semestinya your M is 3. Tapi in this value, we will call it -1, kosong, and +1. This is how you write down. Okay, remember. N, L, M, S. Dekat sini, M kamu masih 3. Tapi when you represent it as a value or subshell, dia akan jadi -1, kosong, +1. We are going to learn this in the next subtopic. Don't worry. For now, stick on 3. Okay? Next. Kenapa 3? Can you see over here? -1, kosong, +1. That's why it's 3. We're going to learn it in detail in the next subtopic. Don't worry. Okay, kalau 2, dia akan jadi apa? Subshell, p orbital. Okay, p orbital. Let me write down here, p orbital, p orbital. Okay. Next, let's continue. Number of orbital 3. Sebab M represents the orientation or number of orbital. Kalau satu orbit ada 2, 3 darab 2 akan jadi 6 electrons. Okay, that is for L equals to 1. Let's have a look at L equals to 2. L equals to 2, your M will be what? 2L plus 1. 2 times 2, 4. 4 plus 1, 5. Kalau 5 jadi apa? D orbital. Kan tadi kita dah belajar, D orbital kan ada 5 jenis. That's why it's 5. So, this one can be represented as -2, -1, kosong, +1, +2. Okay, benda ni we'll discuss later on, jangan risau. D orbital, number of orbital 5. Number of electrons 5 darab 2, 10 electrons. Now, last one, L equals to 3. M kamu akan equals to berapa? 3 darab 2, 6. Tambah 1, 7. 7. So, F orbital. Tapi jangan risau, F orbital we won't be going in detail. Okay, F orbital. Next, your number of orbitals 7. Number of electrons, kalau satu orbital maksimum 2 electrons, 7 orbital darab 2, 14 electron. That is what and how M works. Okay, N, L, M, settle sudah. Sekarang S. Let's have a look at what is S. Okay, let me use purple color. Okay, S over here means electron spin quantum number. Okay, just now we know that one orbital takes up maximum 2 electrons kan? Okay, you have to know electrons behave as if it was spinning. Okay, spinning down, spinning. Okay, dia punya behavior adalah spinning, and it can only spin only at 2 directions. So dia macam ni, atas atau bawah. Okay, the spins 2 direction je. Okay, S can only be 2 things, positive 1/2, negative 1/2. The drawing we will learn in this next session. Positive, I'm just going to intro a little bit. Positive 1/2 means ke atas macam ni. Negative 1/2 ke bawah macam ni. Okay, the arrow is not like this, you know. Nope, the arrow is like this. Kalau ke bawah macam ni, ke atas macam ni. Okay, alright, 2 direction. And for this value is positive 1/2, for this value negative 1/2. Alright, I guess that's all for quantum mechanical model. We have covered every single thing about quantum mechanical model and the basics of it. For the next session, we are going to learn on electronic configuration, which is very related to quantum mechanical model, and we are going to learn on drawings and so on. So please remember and bear in mind NLMS and everything about it. Alright guys, I hope you guys enjoyed the session for today. Happy study. Thank you very much.